Hey guys, welcome back to another round of chemistry notes. In this video, we are going to talk about chemical reactions. Really, the whole unit is going to be about chemical reactions. So in this video, we are going to just start off. All right, so a chemical reaction is the process by which one or more substances are changed into one or more different substances. At the beginning of the year, we talked about chemical versus physical changes and how in a physical change, you still have the same thing at the beginning and end of a reaction. In a chemical change, in a chemical reaction, that's not true. We're changing into something completely new here. So your chemical reactions consist of two parts. They consist of the reactants, which are the things you start with, and you have your products, which are the things you end up with. There are a couple of different ways of describing chemical reactions, and you need to be familiar with all of these. You can describe them with a formula, with an equation, which is really sort of like the equations you see in math class. You've got one thing plus another thing is equal to, this arrow means equal to, we'll talk about that in just a second, is equal to something plus another thing. It's really just like a mathematical equation, but with chemicals. So that's one way to represent it. We can also do that with a sentence, such as methane reacts with oxygen gas to form carbon dioxide and water vapor. That's describing this exact same thing we have up here. This is methane reacting with oxygen gas to form, the arrow means equal, it also means to form, carbon dioxide and water. The third way that we can talk about chemical equations, chemical reactions, is in a picture with a particle representation. So what you see here are two different ways of doing that. And these again are still describing that exact same equation. So we've got this shape right here is one carbon atom in the center and 4 hydrogen atoms. So this is CH4, otherwise known as methane. And then we have these two sets of atoms. These are each an oxygen molecule. So we've got methane reacting with oxygen to create this right here. The black atom is carbon and the red atoms are oxygen. So this is CO2, carbon dioxide. And here we've got one oxygen and 2 hydrogens, or H2O. So again, we're still describing the reaction of methane with oxygen to create carbon dioxide and water. Or here, with the actual Lewis structures, like we learned how to draw earlier in the year, CH4 plus O2 and O2 gives us 2 waters and 1 carbon dioxide. And it's important to notice, you may be thinking like, well, why do we have to put water in here twice? Why? That's oxygen. You may be thinking, why do we have to put oxygen in here twice? Why can we not just put, the 1 oxygen and the 1 water and call it a day? And it comes down to the fact that we're starting here with 1 carbon atom and 1, 2, 3, 4 hydrogen atoms and 1, 2, 3, 4 oxygen atoms. So we better end up with that same number of atoms because, again, we learned this way, way earlier in the year. We talked about Dalton and his atomic theory. He said atoms cannot be created or destroyed. So if we start with 4 hydrogen atoms, we better end up with 4 hydrogen atoms. We'll talk about that in just a little bit. But again, using those vocab words we learned earlier, the things you start with, the methane and the oxygen, no matter how you draw them, if they're drawn like this, or if they're drawn like this, or if they are drawn like this, or as methane and oxygen gas. In any case, the things that you start with are the reactants. So these here on this side of our arrow, these are the reactants. The things you end up with, the carbon dioxide and the water, or the carbon dioxide and the water, however it's drawn, however it's represented, the things you end up with, those are the products. All right, so let's talk a little bit more about these symbols. So that arrow that we saw earlier said it's like an equal sign. in a math equation. It means forms or produces or yields. It means everything that was over here is going to do something, and in the end we are going to get this thing over here. You'll start seeing a lot of state symbols pop up. We talked about these earlier this year, but it's been a while. If you see an S in parentheses following an element, so for example, if you have like Mg followed by an S, this means solid magnesium or magnesium metal. If you see an L in parentheses, that means something is in the liquid state, such as H2O in parentheses. When we draw it by hand, or when I draw it by hand, I tend to draw that L in cursive, just to make it a little more clear that it's an L and not a 1 or a capital I. But H2O with that L in parentheses means liquid water, the water you drink, as opposed to an ice cube or steam. Steam would be H2O in the gaseous state, right? It's a gas. Or aqueous solution, meaning dissolved in water. So when you see the word solution, it's always going to be AQ for aqueous. Some different versions of the arrow that you can have are to put a delta above it or to put the word heat above it. Oh, it's operator error. Dang. Oh well. Both of these mean that the reactants have been heated. It means while we are undergoing this arrow process to get from the reactants to the products, we are putting some heat in there as well. Or sometimes you'll see a chemical name such as MnO2. That means that we've put a chemical in here to speed up the reaction, but it's a very special type of chemical called a catalyst. You should have learned about those in biology. Remember, a catalyst is something that is used in a reaction, but it's not used up. This is not a reactant, it's not a product, it's still going to be the exact same at the end of our reaction. So you'll see these a lot popping up. We'll sort of explain them again as they go. Just these are different clarifications, symbols that you should know in your chemical equations. All right, let's talk about our stages of a chemical reaction. They occur in 3 stages. The first stage is that bonds need to break in the reactants. They need to break in the reactants so that we can have stage 2, which is the atoms rearrange. So we break apart all of our atoms, they reorganize into new stuff, they go find new partners, new atoms to hang out with, and once they are reorganized into a new organization, the bonds in those atoms reform into the products. We form new bonds in the products. And again, I cannot stress this enough, the atoms are neither created nor destroyed. The bonds are created, the bonds are destroyed. That happens so that the atoms can rearrange. But the atoms themselves are not created or destroyed. If you start with 12 magnesium atoms, you are going to end with exactly 12 magnesium atoms. All right, so some signs of a chemical reaction. There is emission of light or heat. We saw this during our flame test lab when we were burning stuff. We saw light and heat. It's called fire when they're mixed together. That's the sign of a chemical reaction. There is formation of a gas. This may look like fizzing or bubbles if it's happening in a liquid. So bubbles can be sort of one part of that. There is formation of something called a precipitate, which is a solid where there didn't used to be a solid. And again, we talked about this during signs of chemical changes. This is not like, oh, I put my liquid ice trays in the freezer and they froze and now it's a solid. I made a precipitate. This is a solid where you wouldn't expect there to be one. I mixed 2 liquids together and now they're solid, and that's weird. That's a precipitate. Then we have energy change. Does it feel hot or does it feel cold? That means it is either absorbing heat or releasing heat. Either way, that is going to be a sign of a chemical reaction. And then again, there is color change, but this is unexpected color change. This is not, I mixed red paint and blue paint together and they made purple paint. That's a physical change. That's exactly what your color wheel tells you is going to happen. This is like, I mixed red liquid and blue liquid together and now it's Yellow, that's not what you would expect to happen. That's a sign a chemical change has occurred. All right, let's go back to this created or destroyed thing. I'm really going to just keep hammering this. It is a law. Matter, atoms, cannot be created or destroyed in a chemical reaction. They can rearrange all day long, but they cannot be created or destroyed. So the total mass of all of your reactants has to equal the total mass of all of your products. They may be distributed differently, but if you start with 50 grams of matter, it might be 2 grams of a solid and 48 grams of liquid. But if you start with 50 grams of matter, you have to end with 50 grams of matter. Even if all 50 are gas, it is still matter and it still has to be 50 grams. So let's put this to work a little bit. If we have chlorine gas reacting with an aqueous solution of aluminum fluoride, we are going to form aluminum chloride in aqueous solution and fluorine gas. That's one way of reading that. This is the formula version. We can say it with our words. We could draw a picture of it if we wanted to, but what we're being asked is to talk about the mass. So we're being told that we have 10 grams of chlorine. So we can start by just plugging that in, just like in a math equation, you can plug in for x, plug in for different variables. Cl2 is 10 grams. So where we have Cl2, we will plug in 10 grams. React with 5 grams of aluminum fluoride. So we have our plus sign from our equation, but instead of writing AlF3, we'll write our 5 grams. Producing, this arrow, remember, means to produce, or it can be an equal sign, 12 grams of aluminum chloride. So this right here, we're going to have 12 grams of it. And then how many grams of fluorine are also produced? So we are looking for this. So we can do plus and leave it as F2. We can call it X. I'm probably going to call it X because it's less writing, but this is what we are going to solve for. Because we know that if we started with 10 plus 5 is 15 grams of reactants, if we started with 15 grams of reactants, we have to end with 15 grams of product. We just have to. So then 10 plus 5 is 15 is equal to 12 grams plus X. Doing a little bit more algebra here, subtract our 12 grams from both sides. We are going to get X is equal to 3 grams of F2. We have to make 3 grams of fluorine in order to obey the law of conservation of mass. We started with 10 plus 5 is 15, so we have to end with 12 plus 3 is 15. This is how much F2 we formed. Let's look at another one. Our second one here, we have 25 grams of chlorine reacting with aluminum fluoride to produce 35 grams of aluminum chloride and 7 grams of fluorine gas. We're going to do the same thing. Just plug in what we know, solve for what we don't. We know that Cl2 is 25 grams. So we'll plug in 25 grams plus AlF3. That's what we're looking for. So we can write AlF3. I'm going to write an X to show that's what we're solving for. We don't know what this is, so we're going to plug in everything else. This arrow, again, we can call an equal sign. AlCl3, we are told that we make 35 grams of AlCl3, so we'll plug in 35 grams plus F2. We are told we have 7 grams of F2, so we'll plug in 7 grams. So again, just a little bit of algebra. We have 25 grams plus some amount of reactant. We know that we ended up with 35 plus 7 is 42 grams of product. When this was all said and done, when we massed out all of our products, we had 42 grams. It means we had to start with 42 grams. So the amount of aluminum fluoride we started with must be 42 minus 25 is going to be X is equal to 17 grams of aluminum fluoride. So again, we are doing algebra to find this, but the reason we're doing this algebra is because we know for absolute certain that we are starting and ending with the exact same number of grams. Let's do one more, a little different. We have the same equation, but now it says if 6 grams of chlorine reacts with 8 grams of aluminum fluoride, what is the total mass of products produced? Well, we know that we have Cl2 is 6 grams, so we'll do 6 grams, plus we know that AlF3 is 8 grams, so we'll write 8 grams. Then we have our arrow, our equal to. But now it's not giving us one product or the other. It's just asking for the total mass of all of this together. We are looking for the total mass of the products. So we've got 6 grams plus 8 grams is 14 grams. Since we started with 14 grams, we must end with 14 grams. So X is the amount of reactant we started with, but it's also the amount of product formed. A lot of people at this point tend to try to go one step farther and say, okay, so we've got 7 grams of aluminum chloride and 7 grams of fluorine. We don't know that. We don't know the exact ratio of each one. All we know is that when you take them together, it's going to be 14 grams. All right, so that's it for this video, just sort of a short, sweet intro to chemical reactions. Moving forward, we'll start looking at different types of reactions. We'll look a little bit more in depth at the equations. But for right now, this is it. So good luck and happy studying.